Okay, now we are starting on Newton's forward differences. We are given n plus 1 equidistant data point. So these two, Newton's forward difference and Newton's backward difference, they require us to have our data points in equal distance. That means x0 to x1, x1 to x2, each of them have the same distance. So you are given n plus 1 point, x0, y0, x1, y1, x2, y2, xn, yn, and the distance between two consecutive axes are fixed, equal distance, which is equal to h. Okay, so what is the forward difference? Forward difference is at any point. Forward difference at any point is the difference between that y value at that point minus y value at the forwarded point. Suppose I am saying I am dividing, this is my x-axis, and I am dividing into equal subintervals, because each of the x right now we need them to be of equal distance. So their distance is h, and you have the corresponding y values, right, at these points. So what is the forward difference at any point is the difference between the forwarded value. So this is the forwarded value and this is the current value. Forwarded value minus the current value. So you can see forward difference at any point xi is yi plus 1 minus yi, and the difference is denoted by a triangle. The second order difference, so this is saying delta square, which is the difference between the first order difference, and so on. So if you want to calculate the third order difference, that will be the difference between the second order differences. So for this one also, Newton's forward difference and Newton's backward difference, you need to also complete the table for the differences, and they will give you the same value. Forward difference table and backward difference, the table will have the same value, but their position will be a little bit changed. Okay, so let's say what are given to us. We have an example here, x and y is equal to f of x. So how many points are given here? 4 points. So that means we have x0, x1, x2 and x3 given, and then corresponding y0, y1, y2 and y3 are given. Okay, now we want to calculate the first order forward difference. What is the first order forward difference? At any point, the first order forward difference is the difference between the forwarded value and the current value. So the forwarded value is 1, current value is 2.5. So first order forward difference is 1 minus 2.5 at this position. Now when we are here, forwarded value minus the current value. So 3.5 minus 1, forwarded value minus current value, so that will be 1.5 minus 3.5, right? So what are these values? 1 minus 2.5 is negative 1.5. 3.5 minus 1 is 2.5. 1.5 minus 3.5 is equal to negative 2, right? Okay, now we are calculating the second order difference, and we say second order difference at the difference of the first order. So 2.5 minus negative 1.5, and then negative 2 minus 2.5. So what is this one? 2.5 plus 1.5, 4, and this one will be negative 4.5. Okay, now we are calculating the third order difference. So what will be the third order difference? Difference between these two. So negative 4.5 minus 4, which is negative 8.5. Now when you are using them in the formula, again you are just using the value in the first row. In forward difference, you are using the values in the first row, and in backward difference you will use the values in the last row. Okay, now the n plus points, the forward difference interpolation formula, now we need to use the table in the formula. The n plus points are given by xi is equal to x0 plus ih. How is that working? Suppose this is your x0, then next one we said the distance is always equal, right, for forward difference. So next one will be x0 plus 1h, then x0 plus 2h, x0 plus 3h, x0 plus 4h, last one will be x0 plus nh, which is xn, right? So xi is any point you can say as x0 plus ih, for which the corresponding y is equal to f of x I are also known. So we already know what are the values of y at these points, but we are trying to find out a formula that will give us an approximation for what is happening between these values. So what is this formula saying? Suppose you have a point somewhere between them and you want to calculate what is the function value at that point. So we are saying suppose this point where we don't know the value, suppose this point can be written as x0 plus sh. We don't know what is that s. We are saying x is equal to, x is the point which one we don't know the value at that point. X is equal to x0 plus sh. Now your x0 is known. You also know what is the common difference between the point. So you can find the value of s if you want to know what is the value, what is this point, right? Okay, so this formula depends on the value of s. This is saying f of x0 plus s times, so this is f of x0 plus s times, let me use another color so you guys can figure out. Okay, so we are saying this is our f of x0 plus s, you are calculating from this relationship, delta, that means first order difference, so this is your first order difference, s times s minus 1 divided by 2 factorial, delta 2, that means second order difference, so this is your second order difference, s times s minus 1 s minus 2 divided by 3 factorial, then this is your third order difference, and so on. So it depends on the table how many values will be given to you. This one have 4 values, so we have differences up to order 3. If you have more points given, then this table will be more bigger, right? Okay, now we want to calculate, this is saying find f of 3.5, find f of 6.5 using the forward difference table. So what is happening? We already know what is y0, we already know what is the first order difference, second order difference, and third order difference. Now suppose I want to calculate what is the function value at x equal to 3.5. So what I'm doing is I'm replacing x by 3.5 is equal to x0, our x0, that means starting point is 3, plus s times, what is the common difference between them? H. 3 to 4.5 is 1.5, 4.5 to 6 is 1.5, 6 to 7.5 is another 1.5. So 1.5, H is 1.5. Okay, now I want to solve this one for s. So minus 3 on both sides. 3.5 minus 3 is 0.5 is equal to s times 1.5. So I am dividing both sides by 1.5, and that will give you s is equal to 1/3. So what you need to do is you need to replace s by 1/3 in this formula. Okay, so what is f of 3.5? F of 3.5 is equal to f of x0, which is 2.5 plus s, we found s is 1/3, first order difference, which is negative 1.5 plus s times s minus 1, so 1/3 times 1/3 minus 1 divided by 2 factorial, which is 2. Second order difference is 4, s times s minus 1, that means 1/3 1/3 minus 1, 1/3 minus 2 divided by 3 factorial. 3 factorial means 3 times 2, 6. And then my third order difference is negative 8.5, negative 8.5. Okay, so you just need to complete this calculation, and that will give you the value of the function when x is equal to 3.5. If you want to find out what is the function value at 6.5, so you want to solve 6.5 is equal to x0 plus sh. Your x0 is again 3 and your h is 1.5. You will solve for s, and in the function you will replace s by that new value. So I am again going to complete this handout and putting that in Canvas handout section.